Hello everyone. Today we are going to solve GFG problem of the day, palindrome sentence. So let's see what the problem says. So in the problem we have been given one string, and in this string we have to tell whether it's a palindrome or not. So what is palindrome means? Like word that is read forward and backward same. So if we see the word radar, RADR, reading from forward, reading from backward also, all the characters are same, RADAR. So this is a palindrome. So whatever is given to us in the input, we have to tell whether it's a palindrome or not. Some cases we have to consider, like if there is something like this. So capital T and a small t we have to consider equal. Spaces between them we have to neglect, and special characters like this dot, this hash, we have to neglect. So we have to take only capital A to Z, 1, 2, 3 like digits, and a small a to z. Only these we have to consider, and we have to neglect these special characters. So the approach that first comes to mind is brute force. Like I will be keep storing each and every word in a string like this. Let me create a string, and I will keep storing each and every word in smaller letters. T O O. I come till this point. Here I have a space. I will neglect it. Then I come here. H O T. Then this. Again I will neglect the space. Then H O O T. Then I will, after storing, what I will do is I will reverse it, like, and I will check whether the original string and the reverse one are equal or not. So if they are equal, that is palindrome. If they are not, it is not a palindrome. So that would be my brute force approach. And what would be the time complexity? So time complexity would be I'm running a loop. So big of 1, big of n, we can say, running a loop in this one. And if I reverse also, so again I will take n, so big of 2n, that will be equal to big of n only. But the space complexity would we will be taking. So space extra also we will be taking O of n. So can we try to optimize the time and space complexity further? We can't optimize the time complexity, but we can optimize the space complexity by having a pointer I here and having a pointer j here. And what we can do is we can keep checking whether smaller, like we will be keep converting everyone to a smaller case and checking whether they are equal or not. So t and t, they are smaller in equal, so I would increase my I by 1 and decrease my j by 1. So my j is here and my I will be increased here. Now O both are equal, so I will increase my I here and I will decrease my j to here. At this point, both are equal. I will increase I and I will decrease j. At this point, you will see I is at a space and we don't want to consider space. So if any of my I or j is at space, I will increase I. And then I check H, both I at H, J at H, both are equal. I will increase my I and I will decrease my J. So J is at space. So I don't want to consider my J like space, so I will decrease J. Now here both are equal. O I will be increased here, J would be decreased here. And now T both are equal and they are at space again. So until and unless my both I and j are not equal, I will be keep running a loop. And here both are like equal. So we can say if till this point we are good, that is a palindrome. And otherwise, let's see if here at it is T, and here it is something like L. I is here, J is here, and they are not equal. We can return here from here and say this is not a palindrome. So the time complexity would be big of n by 2, but generally it would be n, and space complexity would be big of 1. So let's see how. Let's go to the code. Let's write the code for this. Let's declare I and j. So I would be staying at 0 and j would be staying at s dot length -1. And now I will run a loop until unless I is less than j. Until that moment we will be keep running our loop. So first case is if at I we have some character other than A to Z or 1, 2, 3, then in that case we will move ahead. So if character dot is letter or digit, so Java provides a method that will check whether this character is letter or digit. So if that character is letter or digit, s dot caret I. If it is not a character or digit, then we have to move. Then in that case, I plus plus. And there can another case, like if at j, it is letter or digit. So for j also we have to consider. So if at j it is not letter or digit, then we have to simply decrease our j. So now we are done. So other cases, if they are both equal or not. So if we will check, let me copy this. So we will check if we will convert both to the lowercase, and we will check if I, whatever is at I, equals to j or not. Not if, just it would be two lowercase. So we will be converting this to lowercase at I and j. We have to increase I, and then we have to decrease j, and other cases else what is the condition it would land to else? It would land to us if they are not equal. So if they are not equal, then in that case we can return simply false. We don't have to check further. And after coming out of loop, if we didn't found anything false, that means everything was true. So let's compile the code. So it is running. Let me try to submit it. So it's getting submit. Today's problem was not that much difficult, but I hope you got the idea. So if you got the idea, you can like the video.